Hi everyone, let's go ahead and get started with factoring polynomials. Factoring is the opposite of distribution. So instead of multiplying, we're going to be dividing with these ones. And let's get started. So first off, I have an example that I'm doing, and then I've left an example there with the solution for you to try. Okay, so on this first one, I am looking at negative 3x squared minus 48x or negative 48x. And I am trying to find what is their greatest common factor. What can they both be divided by that I can factor out of the group? So I said group. That means I'm going to put parentheses around it. Okay. Now I want my first term in the group to be positive whenever possible. So I'm going to factor out a negative. Now, when I factor out a negative, that's going to make everything change operations. So instead of being a negative 3x, it would be a positive 3x. Instead of being a negative 48, it would be a positive 48. They also can both be divided by 3. And they both have at least one x that I can factor out as part of my GCF. So when I divide out, or when I factor out negative 3x, that very first term, I'm only left with a positive x. When I take negative 48x and factor out negative 3x, I am left with positive 16. Now, I can always check my work by remultiplying that, redistributing that. So negative 3x times x still gives me negative 3x squared. And negative 3x times positive 16 gives me negative 48x. So always go back, check your work whenever you need to. Make sure that you factored out that greatest common factor correctly. Okay, so this would be the factored form when I am factoring out a GCF out of that expression. Okay, here's one for you to try. Actually try it, then check that solution. Make sure you're getting those same numbers. Okay, all right, let's go into another one. Now this one here, instead of a binomial, I have a trinomial, and I'm trying to see what is it that I can factor out of all three terms. Now on this one here, again, that first term is negative in the group, and I want it to be positive. So when I factor that out, I'm going to factor out a 9. Oh, sorry, a negative. Now 9, 27, and 6, they can all be divided by 3. And in this case, they don't all have an x. Only the first term and the second term have an x. So I cannot factor out an x in this one. So negative 9 divided by negative 3 gives me positive 3. And I'm not factoring out any x's, so it's still x squared. Positive 27 divided by negative 3 gives me negative 9, and it still has x. 6 divided by negative 3 gives me negative 2. Okay, so factoring out that GCF is dividing by the one value or value and variable that we can fairly divide out of all three terms. All right, again, you can always check it by multiplying them back together to see if you get to your original polynomial that you had there. All right, let's go on to the next one. Now, on this next one, I have 4 terms. Now, when I've got 4 terms, again, first thing I'm going to do is look for a GCF. There's actually 2 ways to do this, but we're going to talk about factoring by grouping in the future, so I'm not going to consider that here. All I'm looking at here is what is the GCF? Is there something that I can divide out of the whole group? We should always look for a GCF first. So here's my group. The first one is positive. Great. I don't have to factor out a negative. We like when that first one is positive in the group. 14, 21, 14, 21. They can all be divided by 7. So 7 is our GCF. They don't all have an x, so I cannot factor out an x. So 14 divided by 7 would leave me with 2, x to the third. Negative 21 divided by 7 would be negative 3, x squared. Positive 14 divided by 7 would leave me with positive 2x. And negative 21 divided by 7 leaves me with negative 3. Again, I could not take out an x because they didn't all have an x available. Okay, so always look at the one that has the smallest and start working with that value. Okay, there's one for you to try. See how you do on that one. All right, let's go on to our next video where we are going to start factoring something. Again, we're going to practice with that area model. All right.